In this video, we're going to look at two examples of matched pair t-tests. So you see a simple random sample of men that are part of the study on yoga and meditation techniques for relieving stress and lowering heart rates. Their heart rates are taken 5 times to get a better idea of their actual heart rate, an average before they're taught meditation techniques and after. Did the technique work for lowering the heart rate? Okay, so I hope it's obvious in this case that it is in fact a t-test, and of course the big reason or big way you typically know is that it is important that the data is paired together. So obviously we don't want to just compare all the befores and like find the average here and all the afters and find the average here. We want to actually say for subject 1 what happened, for subject 2 what happened, for subject 3 and so on. This is different than what's called a two-sample t-test, where we actually do keep the samples different because they can't be kind of paired together, or it's not important that they're paired together. In this case, it is important. So the first thing I think we'll do, let's do our state. Okay, so state. Remember, state is typically just talking about the null and alternative. Our null, since it's a matched pair, is that the difference, the average difference, is 0. Remember, another way you can write this, and I'm just going to write this off to the side because you don't have to do both, is that mu of after minus mu of before equals 0. Okay, maybe that's a little bit nicer way to write it. It's a little more obvious of what we're talking about. The alternative in this case is that the average difference in this case is less than 0, because we think that the mu after minus mu before, the after should be smaller. Their heart rate should have gone down. So if you've done it the way I've done in black, then you just need to say that mu sub d is the difference in heart rates for all men, and then maybe you want to say it's the after minus before, so they're clear when grading yours what exactly which way you've done this. Okay, so that's our state. Next, our plan. Well, our plan, we have to first of all say that we'd like to do a t-test. Okay. It does say it was a simple random sample, so that's our condition. Oh, by the way, with t-tests, let's also say we're doing a matched pair. Let's be clear that that is the type of test we're doing. We have 9 men, so 9 is less than or equal to 1/10. All men, maybe that would learn the technique. Okay, we're trying to generalize this a little bit. Now, 9 is a very small sample size, so of course we are going to need to do a graphical check. Now, the graphical check we're going to need to do is not on the individual before and after, rather it's on the difference. Okay, so let me bring that in here. Alright, so let me show you what I've just put in here. Up here, I have put in the before, after, and I did after minus before as I wrote here, and I got a lot of negative numbers, which makes sense. We're trying to lower the heart rate. So then I did a plot on my calculator of that. Please remember, when you're doing this, the reason we use this plot is it's simple. It shows us that if there are outliers, there aren't. There is a little bit of skew here, but at least we can say there are no outliers and a slight skew, but we're going to be okay proceeding here. Okay. Now, the other thing to remember is you do need to include an axis and some labeling. Okay, so don't forget that. All right, so now we are to the step where we can do. So this we're going to do the t-test in the calculator. So let me bring that in. Alright, so again, let me show you what I've got here. I went into my test menu. I'm using data. I'm just going to use my list 3 and make sure you remember you are doing the differences. My mu, or my null, was that mu was 0. And we keep these the same. We have less than here, so we should have less than here. And then I calculated, I got a t statistic with 8 degrees of freedom of negative 1.639. And I got a p-value of 0.07. Okay, so now I can conclude. I'll move things out of the way. I conclude. We fail to reject the null. The reason, our p-value that we calculated was greater than 0.05. Now we have to put this in context. So we have insufficient evidence, or we could just say we don't have enough evidence that the yoga technique lowers heart rate. Of men. Okay? In this example, an anthropologist at a university wants to determine if there is evidence that 18-year-old males tend to be taller than their fathers. To answer this question, he took a simple random sample of 12 pairs of fathers and sons. Is there evidence at the 0.05 level? So again, what we don't want to do is just say, okay, let's compare all the sons, let's find the average here, and let's find the average here. It is important we are comparing a father to his own son, or a son to his own father. So we do want to keep them in pairs. So it is a matched pair. So starting off with our null. The null is that the difference between the two is 0. The alternative, well, in this case, we're trying to show that the son is greater than the father. So let's do this. Let's make a mu difference greater than 0. And we'll define that mu difference as the difference between the height of the son and father. And again, it's kind of nice if you wrote your null as, mu son minus mu father, which is kind of nice. If you didn't, it'd be nice right here to say you did the son minus the father. Okay? All right, so there's our state, our plan. Well, we're going to do a match pair t-test. It told us there was a simple random sample. Obviously 12 is less than or equal to 1/10 all fathers and sons. We have a small sample size. So once again, I'm going to bring in my my plot, and I'll show you what I did here. All right, so once again, you can see I brought in my here's the son's height, father's height. I did son minus father. Okay, here's my plot of list 3. Remember, I want the plot of the differences. That is what my null and alternative concern. Remember your scale on the bottom. We definitely don't see any outliers, and not much skew either. Okay. So now we do. Again, this time we have the data, so I'm going to just do the t-test real quick. Okay, so here we are. Again, I'm using data null. I was comparing the list 3 because that's the differences. This should be greater because this is greater, and I calculate it. I come up with a t with 11 degrees of freedom equal to 2.12. A p-value of 0.0 0.29. Okay, so I'm going to throw this over here. Maybe this over here. My conclude, I would reject the null. Again, say why. It's because your p-value is less than 0.05. What does that mean in context? It means that sons tend to be taller than their fathers.